Hello and welcome back. We are going to be continuing our Algebra 2 review with fractional expressions. We're going to start with adding and subtracting fractions and then getting a little more complicated with fractional expressions that include x and y and canceling. My rule of thumb for algebra is if you can't do it with numbers, you cannot do it with letters. So let's get started looking at how to write as a single fraction. That means add or subtract, multiply or divide. And if we start out, this first one's easy peasy because you've got the same denominator, 32. So all you do with this is subtract the numerator, 17 minus 9, to give you 8. Then to simplify, normally you've learned to slash it out, divide the top and bottom by 4. But just because we're going to be going into algebra, I'm going to write it a different way. I'm going to say 8 is the same as 8 times 1, and 32 is the same as 8 times 4. 8 over 8 is 1, so we can cancel those out. So we end up with 1/4. The reason I wrote it this way is so that you see that you can cancel like factors. And when you do that really quickly and you say this is 1, this is 4, this is actually what's going on in your brain. So let's look at number 2, 33 over 25 times 20 over 77. I'm going to take the long way and I'm going to go ahead and break these apart. So 7 times 11, 3 times 11, so my 11s are going to cancel out. 5 times 5 is 25, and 5 times 4 is 20. So my 5s are going to cancel out there. Then when you multiply across, so 3 times 4 is 12, and 5 times 7 is going to be 35. So you're going to have 12 out of 35. When you're adding three fractions together like this, adding and subtracting them, remember just take them 2 at a time. So I switched the order because 6 and 35, that's going to be a pretty big number. I switched it so that I had 1/6 minus 4/15 plus 6 over 35, but you can take them any 2 at a time. The reason I chose 6 and 15 is because they both go into 30, and that's an easy number to work with. So I'm going to take and make this 1/6 something out of 30, an equivalent fraction out of 30, which is going to be 5 out of 30, and my 4 over 15, I'm going to take and make that as 8 out of 30, because 15 times 2 is 30, so I take my 4 times 2 to get 8. I just deal with those two first, so I end up with negative 3 over 30, and add on the 6 over 35. This makes it easy. I can reduce this negative 3 over 30 to negative 1/10, and 6 over 35. Now, to find a common denominator between these two fractions, 70 is the number I come up with, and I'm going to multiply the top and the bottom of this one times 7, and the top and the bottom of this one times 2. So I'd end up with negative 7 over 70 plus 12 over 70. When I add those together, I get 5 over 70, and 5 does divide into 70 14 times, so you end up with 1 over 14. If you do not know how to add and subtract fractions and multiply and divide fractions, then when we get into adding all the variables in, it's going to be difficult for you. So I suggest making sure you know these rules first because they apply to the formulas. So another thing we had to do is find the domain. We care about the domain because that is where our function is defined. So just as a quickie, you cannot have zeros in the denominator, so I check and see if my expression has a denominator with an x in it, and I make sure that the x cannot equal anything that would make the denominator 0, because that would make our function undefined. And you cannot have a negative under even roots. I know those are imaginary numbers, however, they're non-real numbers. And the last way to check the domain is to graph it. You look at the span of how your graph goes from left to right. If there's any gaps or jumps as you go left to right, those numbers have to be left out of the domain. You can also check for asymptotes, vertical asymptotes, and if there's like a vertical asymptote at x equal 2, then x equal 2 is not in your domain. Looking at this first one, number 4, 2x minus 5, there are no fractions and there's no roots. So right away, this is all reals. If we would graph that, that would be a line going left to right, and you would say the span goes forever. There's no gaps, there's no jumps. For the next one, you have a square root and you have an x in the denominator. Well, you know your denominator cannot equal 0, and you have to have a positive, it has to be 0 or greater under the root. So I'm going to say that this one, x minus 3, has to be strictly greater than 0. If this was just by itself, it'd be greater than or equal to 0, but since it's in the denominator, it cannot equal 0. By the way, back here, that's how you represent all real numbers in interval notation. So x minus 3 has to be greater than 0, and we're going to have x greater than 3. So that is our domain, all positives from 3 to infinity. Number 6, you have an x in the denominator here, and what you need to do is say, well, I cannot have a 0 in the denominator. So what would make the denominator equal 0? So we say x minus 2 cannot equal 0, which means x cannot equal 2 because 2 minus 2 is 0, and that makes our function undefined. And you can write this in words, all reals except for 2, that's fine. If you were doing it in interval notation, you would say negative infinity to 2, union 2 to positive infinity, but I didn't do that in this case. Part 3 of your assignment is going to be to find missing numerators or denominators. What you have to do is say, how do I go from the 5 to the 15y? So what did I multiply by? Well, I multiplied by 3y. I have to multiply the denominator by the exact same thing to keep these fractions equal. 3y over 3y is 1. Any number times 1 is itself. So this ends up to be 6y squared, and yet that's your answer. This next one's a little bit different. It's got x squared minus 9, and you've got an x minus 3 here. You have to look at this simpler one. How would it get from here to x squared minus 9? I factor x squared minus 9 as x plus 3 times x minus 3. So what this means is I multiplied this x minus 3 times x plus 3. So that means I have to do the exact same thing to my numerator. So I'm going to multiply that times x plus 3. Now you've got a trinomial times a binomial, which means you got to take your time and multiply it all out. So I'm going to take this x times my x squared. That's going to give me x cubed. Then I take my x times my x, that gives me an x squared, and then I take my x times the minus 6, and that's going to give me a negative 6x. Then I got to take the 3 times each of these terms. So if I multiply the 3 by x squared, I get 3x squared. And I like to do the vertical alignment so my like terms all line up. Then I take my 3 times my x and my 3 times my minus 6, which gives me minus 18. Add them up vertically. Your like terms are grouped together, so that's x cubed plus 4x squared minus 3x minus 18. And you're done. That's what the new numerator would be. Write in reduced form. That means take out like factors. So 75y squared over 9y to the 4th. Remember that you subtract exponents that are on the same base when they're in a fractional form. So you can only cancel factors. So like in number 11, we're going to have to factor first. So I would express this 75 as 3 times 25 times y squared, and then 9 as 3 times 3 times y to the 4th. 3 over 3 cancels out because that's just 1. And I can subtract this 2 from this y to the 4th, 4 minus 2, to bring it downstairs. So we end up with 25 over 3y to the 2nd, and that's it. This guy, it is very much human nature to take and start slashing the x squareds and the x's and all that, but you cannot do that. It's not legal. 1 plus 2 over 2 is 3 over 2. It's not 1. So you have to factor everything out first. So x squared plus 6x plus 9 factors to x plus 3 times x plus 3. X squared minus x minus 12 factors to x plus 3 times x minus 4. We practiced that the last section. So then we've got common factors of x plus 3 and x plus 3. You can only cancel factors. So we end up with x plus 3 over x minus 4, and we're done. Simplifying these. Again, when you see this minus or plus, that means I got to factor first before I can start slashing and burning. So I'm going to take and factor out a 3x. It'd be 6x minus 1, and then I can write everything on the top as a list of factors. So 3x times 6x minus 1 times 12y squared divided by 3xy times 6x minus 1. Now everything's multiplied. They're all factors, so I can start slashing and burning. So we slash and burn the 3x, slash and burn the 6x minus 1, and then this y will cancel with one of the y's up there. So I'm going to take that y away from the one upstairs. Then I look across, what have I got left? I've got a 12 and a y left. That's it. Done. Fraction within a fraction. These are called complex fractions. If you have one fraction over one fraction, you can flip the bottom one and multiply, because it's like this guy divided by this guy. So I'm going to take and I'm going to invert and multiply. So instead of having y squared minus x squared on top, that's going to be on the bottom. So flip them around. Then I cannot do anything until I factor. I've got a minus here and a minus here. I cannot factor differences or sum, or I cannot cancel differences or sum. I can only cancel factors. So when I factor this one out, I get x plus y times x minus y. Then I'll bring up the 4x squared y. It's going to be all over 2xy times y plus x, y minus x. So when you factor that out, I know right away I can slash and burn some things. The x plus y is the same as y plus x. This I'm going to leave till later. And 2 goes into 4 twice. X will cancel with one of these x's here, so I'm going to have x, and that's going to subtract 1 there. And the y's will cancel. This y will cancel with this y. Alright, what have I got left? I've got an x minus y times 2 times x on the top. So I'm going to have that, and then on the bottom I've just got a y minus x. This is a nice little tool to have in your arsenal. X minus y, y minus x. These are opposites. X minus y is the opposite of y minus x. So they divide into each other with the quotient of -1. So x minus y times x on the top, 2x on the top, and the opposite of x minus y on the bottom. This is the same as this. So we can take the opposite of it. Those will slash and burn, and we end up with just a -2x. Adding and subtracting, part 4. So when we add or subtract, remember, just like with regular fractions, with numbers, you have to have the same denominator. So 3 over x minus 2 plus x plus 1 over x minus 2. They have the same denominator. So you can rewrite this as 3 plus x plus 1 divided by x minus 2. Combine your like terms, you'll have x plus 4 over x minus 2. Cannot cancel the 2 and the 4 because it's a sum, not a list of factors. Here we go. The fun begins. We've got 5 over x squared plus x minus 6 minus 2 over x minus 2 plus 4 over x squared minus 4. Now, you can take it the long, long way and multiply all these to get your least common denominators, but I would factor first and then see what we need. So I'm going to factor that x squared plus x minus 6. That's x plus 3, x minus 2. And then x squared minus 4 is x plus 2, x minus 2. Our least common denominator has to have all of these factors in it. Well, we need an x plus 3, an x minus 2. That'll take care of this guy, and an x plus 2. So my least common denominator is going to be the product of those three things. X plus 3 times x plus 2 times x minus 2. When we go to rewrite these with our least common denominator, I look at this first one and I say, what is he missing out of the least common denominator? Well, this one is missing an x plus 2. I have x plus 3, x minus 2, but I don't have an x plus 2. So what I'm going to do is say I'm going to take the top and bottom times x plus 2. And then instead of writing that big long honking thing, I'm just going to put LCD. For the next fraction, 2 over x minus 2, it's missing the x plus 3 and the x plus 2. So I have to multiply it times both of those things. And then it would be over my least common denominator. And the final fraction is missing the x plus 3. It has x plus 2, x minus 2. It's lacking this one to be over the least common denominator. So I'm going to have plus 4 times x plus 3 over the LCD. I wrote it this way just to keep it kind of simple. I need to now simplify all of these numerators. That means multiply everything out and combine like terms. So I'm going to take this -2 would be times x squared plus 5x plus 6, and we're going to have 5x plus 10, and then we'll have minus 2x squared minus 10x. When I take this minus 12, and the 4 times the x plus 3 gives me 4x plus 12. Notice they're color coordinated so you can see where the like terms are. That's going to be a negative 5x plus 4x, which is a minus x. So we would have this all divided by our least common denominator, which is going to give us negative 2x squared minus x plus 10 when we combine our like terms, over our least common denominator. Now I factored out a negative 1 there. Don't necessarily have to do that. But we can see if that 2x squared plus x minus 10 factors, are there two factors of 20 that add up to 1 in the middle? 4 and 5. That's what our inner and outer terms have to be. So this would be 2x squared plus x minus 10 factors as 2x plus 5 times x minus 2 over our least common denominator, and we can slash and burn the x minus 2. So there's our final answer. Are they going to take a little bit of time? Yeah, they're going to take a little bit of time, but just take your time on them. You don't have that many to do, but you do need to practice it. Okay, that's it. See you tomorrow.